Alright, this is going to be a walkthrough on programming the Milltronics lathe. Fairly simple part. So we'll be making this guy, which is a little A2 tube, 787 diameter, 630 through, 3.937 overall length. So we're going to start a new program. So you'll say program, conversational, new. It's going to ask you for a program number. I usually use, whenever it's a simple thing like this, I usually just stay in between like 498 and 507. Any of those will be open. There won't be any programs that I need to save on here. And like a lot of times, if it's multiple operations, I'll do first off is 498, second is 499, and just kind of work my way through it like that. So we'll start with 498 here. Enter. It's going to tell me that its existing program will be deleted. That's fine, so I'll hit OK. OK. Now this is my program setup. If I was going to give it a name, you can name it there. Usually don't worry about it on these simple ones. It's going to ask you for material length and diameter. This is only for graphing purposes. It's not going to do anything with your actual program. It's only whenever you verify it and it comes up and shows your block of material there, that's all that does. So let's say our material is 4 inches long and 1 inch in diameter. So 4 point in the length, 1 point in diameter, store. Okay, now we're going to call up our tool. So tool 6 is our most commonly used turning and facing tool. So we'll do 6. Don't need a description. Speed per revolution, I usually do about 10 thou. Max RPMs, I usually do about 1250. In A2, I stick to around 300 to 350 surface foot, so we'll shoot right for the middle at 325. Spindle direction, 99% of the time is going to be clockwise. Coolant, toggle that on. Store. Now we're going to pick what operation we want to do. First, we're going to be facing this off. So we're going to face it. Rough face. How much material do we want on our X? Don't need any X stock. We'll leave 5 thou on our Z. These you never really use, but it has to have input in them, so just put a 0 and a 0. First X step. So this is pretty self-explanatory, but the first pass is going to be at 100 thou deep. Cut increment is going to be, I usually stick to 10 thou on A2. Some of your softer stuff you can bump it up to 15, sometimes 20. Usually do about 50 thou clearance. Won't need compensation on a facing program. With our material being 1 inch in diameter, we're going to start with about 1.2 on our X and 0.1 on our Z. The start point needs to be greater than any value that you have in your program. So if I put 1.2 here, and then later on in my program I end up coming out to 1.3, it's going to confuse this thing. It's not going to do what you want it to do. So just make sure that you always start out further than any movement that you will have in your program. Your pattern number is basically just to establish your relationship between your roughing and your finishing, so that it knows whenever you call up your finishing later, you can say pattern 1. It knows exactly what lines you're talking about, what relationship you want to have there. So got our pattern number 1. We'll store that, and then you want to lay out your geometry, which you do through your lines here. We're going to call up a line. Our first line is going to be a rapid, so we can toggle that to a rapid, and we're going to go to Z0. since we'll be off of our material, we won't be touching anything. That'll just save us a little bit of time whenever we go to do our finish pass, basically. We'll store that. You want to store after every line. So then we got our rapid to Z0. We're going to do a line. The speed rate will be called up from whenever we call up our tool and we put in that feet per revolution. If we leave this blank, it's going to understand that we just want to stick with that. Then we're going to go minus 0.1, and that'll to go past our center point, clean up the face of our part. Store. That's all we'll need for our finish, or for our spacing pass. So I'm going to end there and store that. Now that I've roughed my face, I'm going to finish. Pattern number was 1. I'm going to do 3 thou per revolution at 300 this surface speed. This spindle speed here is on your finish pass is going to be your surface speed. So don't go trying to put in 1200 or something like we did for our RPM, because then you end up going way too fast. The start point will do the same that we did for our roughing, but it's essentially where your rapid position. So we're going to store that and then end again. So we did a rough, laid out our geometry, ended, did a finish, and then end that as well. Okay, now we're going to be using that same tool to actually, never mind, no we won't. We're going to go ahead and bore this thing out. So what we're going to do is go back, move to a safe tool change position. I usually just do 10 inches and 10 inches in both, and store that. And then we're going to call up our drill, which will be tool 4. 2 thou per revolution. We're going to use a 600 thou drill, so we'll go relatively slow. We'll say, let's go 350 RPMs. Surface speed doesn't really matter because you're going to be on X0, so it's always just going to go to straight up to your max, whatever you set your max RPM for. Spindle on clockwise, coolant on, store. Now when you're drilling, you want to move to position before you drill. So we're going to go position. It's going to be a rapid. X0, I usually go to Z.5. Store. Then we're going to drill. And we're going to toggle that so we get drill peck cycle. Re-enter our 2 thou per revolution. Our clearance is going to be your rapid height, basically. So I'm going to do 0.1, and that's also how far it's going to retract in between pecks. Our final depth. Our part is about 4 inches long. 600 thou drill, so that's 0.6, 3 plus 4. We go minus 4.25. First step, I usually do 50 thou and then 100 thou peck and 50 thou peck clearance. Store. Alright, so that got our drill through there. So now we're going to finish it with the boring tool. So we're going to move back out to a safe position. 10 and 10. Store. Call up another tool. Our boring bars are usually in tool holder number 3. This one's going relatively deep in a somewhat small hole, so I'm going to keep my feed relatively light at 5 thou per revolution. Max my RPMs out at 1200, 300 surface foot. Spindle on, coolant on, store. Now we're going to be turning, which is, boring is a turning operation. And we're going to be roughing that bore. Okay, your X finish stock when you're working on a bore or anything that's on the inside of your part is going to be a negative number. You'll be staying closer to 0, and as you go positive, you move further out. So we're going to do negative 5 thou. Z, I usually only do 1 thou on the Z whenever I'm boring, just so that whenever it does go back into the back of your part, it's not trying to dig into that back wall on your finish pass. So 1 thou there. Again, we don't need these, but since they're red, they do need input. So just 0 and 0. First X step. We use a 600 thou drill. So my first X step, I'm just going to do that 600 thou again, just to go in there and smooth up any kind of inconsistencies and stuff before it actually gets to cutting. 10 thou increment on your depth of cut, which is going to be 20 thou for your diameter. I usually, on these smaller diameters, I keep my clearance pretty low, 10 thou, just so I'm not coming off and running my boring bar into the far side of the part. Our start point, I usually just use my first depth of cut on these bores, sometimes a little bit smaller if I have more room to play with it just being 5/8 basically going through, it's kind of tight. So, and start out 100 thou. This is going to be pattern number 2. 1 was our facing, now we're on pattern 2. Store that. Now we're going to lay out our geometry. So we got a line. First one's going to be a rapid. I usually put in a safety move here, just to kind of, I just get in the habit of it because it works better if you have cutter comp on, to have a safety move before and after your operation. So I'm going to, starting at point 1, store that. Then we're going to do another line, toggle it out, and we're going to 630. So I'm going to wrap it out to 630. Store, line. I'm going to feed through my part, which I'm going to need to go down to about 4 inches to get through the whole thing. So I'm going to put in -4 point, store, and then I'm going to do a safety move, or clearance move, to get it off of that wall basically. So we'll go back out to 0.6, or back into 0.6, store. Now we're going to fetch out our geometry. We came into position, moved out, fed through, moved away from the wall. That's all we need to do. So we're going to end that, store it, and we're going to finish it. It's pattern number 2. Again, being boring bar, stick it out a good bit, and being a relatively small hole, I'm going to go relatively slow. So 2 thou per foot, or per revolution, 300 surface foot. Starting point, we'll use those same numbers again, just for consistency. So 0.6, 0.1, store, end again. Okay, and then when you go back, position 10, and I usually go to Z20, and that will be that. That'll be that for that operation. And verify. So going to face it, drilling, and then little boring operation. And then I'm going to have my part a little bit long. I should have thought about that before, but I'll leave an extra ½ inch back here, and then hold on to that, put a center in, turn my outside. So I'll do an outside turning for that second operation now. So we'll exit that. We know that program's good. That was 498. So we're going to do another new program at 499. Okay. Material length. We'll do the 4.5 just so it shows that extra ½ inch that I have in my chuck. Diameter is 1 inch. Store. We can call up our tool. So you basically, every time you'll lay out your material, call up your tool, select operation. So laid out our material, calling up our tool 6, speed per revolution 10 thou, 1250 max RPMs at 325 surface foot. Turn our spindle on clockwise, turn our coolant on, store. Now we're going to be turning, this time on the outside, so turning, rough. Now we're on the outside, our X finish stock is going to be positive. So there's 5 thou there, 2 thou on the outside, and that's the same thing, like just for some of these things where you're coming up to a wall and stuff like that, I usually just do 2 thou just so whenever it goes for the finish pass, it's not trying to dig into that back wall whenever it gets there with the tool. Again, don't need these, but they need input. First X step for 1 inch material, so I usually just do that 1 inch just to, in case it's oversized or it's got any wobble to it, just do a little cleanup pass. 10 thou cut increment, which will be 20 thou in diameter. Clearance 50 thou. Starting point, again, you're just gonna, just anywhere off of your part that'll be greater than any value that you might need to use to lay out the geometry of your part. So 1.2 and 0.1. This is gonna be a new program, so we'll be back on pattern number 1. Enter and store that. Now we're gonna lay out our lines. So our line, first one again is gonna be a toggle and a safety move. Or a rapid, I meant, not a toggle. So the second one will also rapid to our X position, which is the 787. So 0.787, store, another line, and this is going to establish our part, so we want just the regular feed, which again is established whenever you, on your tool call out page, whenever you do your feed per revolution. And we're going to go to Z negative 4 inches. Store, and then line, and we're going to do another safety move. Just go out to 1 inch there, which will clean up our material, get us away from our part and stuff, so whenever we go to wrap it away. In store. We're going to finish that. That was pattern number 1. Do a 3 thou feed rate, 300 surface foot. Start point, do the same for consistency. Store, and store that. And we're gonna go back. I'm gonna move away from our part. X 10 inches, and Z I'm just gonna do 2 inches because I'm gonna have my center up against the end of my part, and this way I'm not, running into that whenever I go to wrap it away. Store, and that should be it to turn it. So we're gonna verify. There's our part. You can see that it displays our 1/2 inch that we have in the chuck because of how we laid out the material. Started out at 1 inch, worked its way in. That's what we wanted. So we'll exit that, exit, exit. And now both of those programs are done. So you would just need to load up your material, touch off your relevant tools, and have at it.